to multiply by the reciprocal of the second fraction. Just watch this arithmetic problem. When you want to take 3/4 and divide it by 7/8, you just need to remember to take 3/4 and multiply it by 8/7. Again, like arithmetic, rational expressions will behave much the same way. Because I have a common factor of 4, which goes into here once, and a 4 which goes into 8 2 times, I can reduce the expression before I multiply. Now I'll go ahead and finish. 3 times 2 is 6, over 1 times 7 is 7, and I've got my results. Again, when you divide with fractions, you invert the second fraction and multiply. That's what we're going to do when we divide rational. Again, don't forget that when you divide, like when you multiply and when you simplify rational expressions, you have to factor everything first. So I prefer, when doing a division problem, to factor the numerators and the denominators of both of these expressions and then to invert the second fraction and multiply. This numerator right here has a greatest common factor of a. I'm going to factor that out first. And when I do, I'll need an a squared plus 4 in the parentheses. Again, check it. A times a squared is a cubed. A times 4 is that 4a. This is the difference of squares. Don't forget to factor that into the product of two binomials. One of them a plus 4, one of them a minus 4. Two trinomials over here where there's a 1 in front of the squared term. So those are the simpler trinomials again to factor. I need an a in the front of each. I now need two numbers whose product is a negative 20. One's got to be positive, one's got to be negative. Those two numbers, 5 and 4, have to add to be 1. So I'm going to put a positive 5 and a minus 4 here so that they add to be that coefficient of 1a. Likewise, up here, I'll factor that into the product of two binomials, an a in the front of each. I'm looking for two numbers whose product is a positive 15 and that add to be 8. So they both have to be positive. Looks like they have to be a 5 and a 3. Please remember, order doesn't matter. I could have put a plus 3 here and a plus 5 there. I'm now ready to follow the process. Remember, we're doing a division problem, so I'm going to multiply by the reciprocal of this fraction over here. So I'm going to put this a plus 5 and the a minus 4 on top, and then this a plus 5 and the a plus 3 downstairs. So there's the reciprocal of the second fraction. The first fraction remains as is. It's got in the numerator an a times a squared plus 4, and then the denominator an a plus 4 times an a minus 4. And like multiplication, so things haven't changed now at this point. At this point we're ready to just reduce common factors. So I see an a plus 5, one on the top and one on the bottom. I see an a minus 4, one over here on the top and one over here on the bottom. And I do not see anything else that's exactly like. It's got to be exactly like. This is a squared plus 4, and this is just a to the first power plus 4. Those cannot be reduced. My answer is going to be written as what's left. I do not have to multiply this out. So in the numerator, I have this a times this a squared plus 4. And in the denominator, I have this a plus 4 and this a plus 3. This division problem is actually much simpler than the last one, but I wanted to show you an example of how you might write an answer when it's all said and done. This numerator cannot be factored. This denominator cannot be factored. That numerator cannot be factored. Only this denominator can be factored into the product of two binomials. One is x plus y, and the other is x minus y. I'm ready now to make this division problem into a multiplication problem. And in doing that, I'm going to take this denominator and put it upstairs. And I'm going to put this numerator downstairs. Because I can't factor it, I'm going to put it in parentheses. It's like saying itself times 1, in case there happened to be another binomial that matched it. Over here, x plus y, I leave that alone. The x minus y, I leave it alone. Again, they couldn't be factored, so it's like, I'm going to put a 1 out here, but it's like saying I have 1 times that x plus y, allowing you to look at that binomial as a factor. Now what I'm going to do is I'm going to remove the common factors, and the only ones that exist are this x minus y and that x minus y, one on top and one on the bottom. You might be inclined to write your answer then as x plus y times x plus y, which is correct. Over the x squared plus the y. Not really necessary to be in parentheses. It can be. Again, if Course Compass gives you any trouble, you need to just write me and tell me you put it in parentheses and you were marked wrong. The other option for writing this is to write this binomial as that binomial squared. That's, if you will, a shorthand way of writing it over the common denominator of x squared plus y. Again, either in parentheses or not.